Okay, in this little shot or video, we're gonna come up with a classic equation. Again, it's a GCSE equation that you probably know, but why and where it comes from is possibly new to you. So it's the equation for resistors in series. What's the equation for total resistance of 3 or more, or however many resistors in series? Well, in order to understand it, we need to remember Ohm's law and the idea of potential and potential difference being the work done per unit charge. So if I said across this cell there is a potential difference, and let's say all of this side, let's say for sake of argument it's a 6 volt cell, and this side's all at 6 volts potential, and all of this side's at 0 volts potential. Now it stands to reason the potential difference across that would be 6. And if these were all identical resistors, if they were, then that would be 4, that would be 2, and that would be 0. So the potential difference between 2 and 0 would be 2. The difference between 4 and 2 would be 2, and the difference between 6 and 4 would be 2. But it doesn't really matter. The point is the potential difference across each resistor is going to add up to the potential difference of the cell. Okay, or the EMF of the cell, we call it, the proper word for it, but the potential difference across the cell is the same as the sum of the potential differences across these things. And so I say, well, think of it like this: V, total voltage, Vt, is equal to V1 plus V2 plus V3. And you'll know Ohm's law, if we just remind ourselves, Ohm's law, V equals IR. Well, we can say, well, this must be the current in the circuit, the current in the cell, I, the total current in the cell, times by the total resistance of the circuit, is equal to I1 R1 plus I2 R2 plus I3 R3. But because we know that the current is the same everywhere, i.e. I1 equals I2 equals I3 equals IR, doesn't matter, the current's the same everywhere, we can divide through and get rid of all the I's, and so we just end up with RT equals R1 plus R2 plus R3. And this is the classic equation for resistors in series. Now what this really means is that if I had 3 resistors in a line, and let's suppose I had a 1 ohm resistor and a 2 ohm resistor and a 3 ohm resistor in a line like this in series, that would give me a total resistance of 6. It would give me a total resistance of 6 ohms. And if I had a 6 volt cell across there, it would mean I'd have 1 amp flowing all the way around it. Okay, but this equation, RT equals R1 plus RT plus R3, and it it goes on. It's not just 3, it's 2 or 4 or 25,000, it doesn't matter. But for resistors in series, the total resistance is the sum of the individual resistances.